Hey everyone, ever feel like the world is run by code you don't understand?
It can feel that way.
Yeah. Today we're diving into designing data-intensive applications
Okay.
to demystify that feeling. At least when it comes to data systems, we're talking databases,
Mm.
indexes,
Right.
all those behind-the-scenes technologies that power our digital lives.
And we're not just here to, tell you about them. We're
Yeah.
giving you the tools to think like the people who actually design these systems.
Exactly. So, no need to become a coding whiz overnight,
Right.
but get ready to unlock that aha moment of realizing how things actually work.
Yeah.
Imagine being able to choose the right database for your startup,
Right.
or finally acing that tech interview because you get it.
It's like getting a backstage pass.
Ooh, I like that.
Yeah. Think about those moments. You're blown away by how fast Google finds what you're looking for.
Oh, every day.
Yeah, it's not magic, it's clever engineering.
Right.
And we're going to break down how that happens.
Okay, so let's unpack why you should even care about this stuff.
Yeah.
We all use apps, browse websites, shop online.
Right.
But what makes those experiences like smooth sailing versus a frustrating crash?
It comes down to how well those systems are designed,
Okay.
which translates to three key things: reliability, scalability, and maintainability.
Buzzwords.
They sound like it, yeah.
But let's get real world here. What do those words mean for everyday users like you and me?
Let's start with reliability. Imagine that sinking feeling when an app crashes and you lose all your data.
The worst.
That's a reliability issue. A reliable system is like a rock, consistently working even when things go wrong. Think of your banking app. You expect your transactions to be recorded accurately no matter what.
Right. And then there's scalability. It's that moment when your favorite app suddenly explodes with a million new users.
Right.
Does it handle the traffic surge or melt down like a server on a hot day?
Exactly. Scalability is about handling growth without breaking a sweat. Picture a website like Netflix
Okay.
that smoothly streams movies to millions of users simultaneously. That's scalability in action.
Okay, and last but certainly not least, there's maintainability,
Right.
which might not sound as exciting as
Right.
massive scalability or whatever, but hear me out.
No, this is important. This is all about making sure these systems are built to last and adapt. A maintainable system is like a well-organized house. You can find things easily, make changes without too much trouble, and it's built on a solid foundation.
So it's not just about the technology itself, but also about making life easier for the people who keep it running smoothly behind the scenes.
Absolutely. Think of it like this: the simpler and more elegant the system, the easier it is to maintain, like a well-oiled machine.
It makes you appreciate those developers even more, doesn't it?
It does.
Now, this actually reminds me of the analogy in the book about comparing data systems to architecture.
Oh, yeah.
Like you wouldn't want to live in a poorly designed building.
Right. Because if you start building with a shaky foundation and a confusing layout, it's a nightmare to maintain. And even dangerous, frankly.
It's all about thinking long term, right?
Right.
So how does all of this tie into data modeling, which seems to be the next big idea?
Well, for a long time, relational databases, those ones with tables and rows,
All right, right.
those were kind of the go-to solution. But then things changed. Remember the whole NoSQL wave?
Oh, yeah. It was everywhere for a while.
It was very trendy.
Right.
Turns out, one size doesn't fit all in the world of data. Different models have different strengths, and choosing the right one depends on what you're building.
So no blindly following trends.
Right.
It's about making smart, informed decisions.
Exactly.
And the book really gets into the specifics of different models, right?
It does, yeah.
Like, what are the pros and cons?
Yeah, one comparison that stood out to me was SQL's relational model versus the document model.
Oh.
Think of JSON, which you see a lot in NoSQL databases.
When I first encountered document databases,
Yeah.
it seemed so different from those traditional tables I was used to.
And for good reason. The book explains why storing certain data, especially when it's highly interconnected,
Okay.
in a document database can be a recipe for disaster.
Okay, now we're getting to the good stuff.
Right.
Can you give me an example?
Yeah. Imagine building a social network.
Go ahead.
You might think it's easier to store everything about a user, their friends, posts, comments,
Yeah.
all in a single document.
Seems like more organized at first glance.
Right. But what happens when you just want a user's friends list?
Uh-oh.
Or the comments on a specific post?
Yeah.
You end up loading way more data than you need?
Right.
making it incredibly inefficient.
It's like, why load the whole grocery store into your car when all you need is a loaf of bread?
Exactly. And that's where that relational model often shines.
Okay.
It's designed to handle those relationships efficiently, so you can grab just the data you need
I see. Absolutely.
without the extra baggage.
So for listeners who are thinking about building their own systems,
Right.
the takeaway here is that there's no single best model.
Right.
It's about choosing the right tool for the job
Exactly.
based on the data you're working with.
Precisely. It's about understanding the trade-offs. Now, speaking of strengths, let's talk about something that makes data retrieval lightning fast. Indexes.
Ooh, yes.
They're the secret sauce behind those. How did they do that so quickly?
You know, this has always blown my mind. You type a few words into Google and bam, millions of results appear, like in milliseconds. How is that even possible?
It's all thanks to indexes. Think of them like the index at the back of a book. They let you jump straight to the relevant page instead of flipping through every single one.
So instead of like painstakingly scanning through mountains of data,
Right.
the system uses an index to pinpoint exactly where the information lives.
Precisely. And there are different types of indexes, each with its own quirks and advantages. The book gets into some fascinating examples like hash indexes versus B trees.
Okay, color me intrigued. Break down
No.
these different types of indexes for me.
Okay. So imagine you're looking up a friend's phone number in your contacts.
Yeah.
You don't scroll through every single contact, right?
Right.
You search by their name.
Yeah.
And your phone instantly pulls up their number. That's like a hash index. Incredibly fast for exact matches.
Okay, so if you're searching for something specific, hash index is the way to go.
You got it. But let's say you're looking for all your friends who live on Main Street.
Okay.
Hash indexes aren't great for that kind of range search.
I see.
Which is where B trees come in.
B trees. I remember those from my computer science days.
Right.
They always seemed a bit complex.
They can be, but their strength lies in their organization. Think of a B tree like a family tree, with branches and sub-branches. It allows the system to quickly narrow down the search space, making it efficient for both exact matches and those everyone living on Main Street type searches.
So a B tree helps the system, eliminate possibilities quickly
Yes.
and zero in on the relevant data.
You got it. Now, the book also dives into this cool thing called an LSM tree,
LSM tree, okay.
which is a specific type of storage engine used in systems like Cassandra and RocksDB. And it leverages a surprisingly familiar concept, the log file.
Wait, log files?
Yeah.
Like the ones on my computer that keep track of errors and stuff?
Similar concept. An LSM tree basically appends all new data to a log file. Then, periodically, it merges and reorganizes those logs into more efficient structures. This makes adding new information incredibly fast. But retrieving it might take a bit longer since the system potentially has to check multiple files.
So it's another trade-off.
Right.
Faster writing, but potentially slower reading.
Exactly.
But for our listeners out there, why should they care about all this indexing stuff?
Right.
How does it impact them?
Think about it. Every time you use a search bar, whether it's on Amazon, Spotify, or even your inbox, you're benefiting from indexing.
Oh, wow.
The speed and efficiency of those searches are directly related to the indexing techniques happening behind the scenes.
So the next time I'm impressed by how quickly I find something online,
Yes.
I'll know it's not magic, it's clever indexing.
It's a clever indexing.
But things get even more mind-boggling when we start talking about data that's distributed, right?
Yes.
What happens when we have so much data
Right.
that it can't fit on a single machine?
That's where the wild world of distributed systems comes in. Now imagine your data living across hundreds, even thousands of machines.
Okay.
That introduces a whole new layer of complexity
Yeah.
and fascinating challenges.
What I'm already picturing things going wrong
Yeah.
when you have so many moving parts.
It's a valid concern. The book dives into these mind-bending concepts like replication and consistency.
Okay.
Essentially, it's about making sure that all those different machines
Right.
have the same up-to-date information and that changes are reflected everywhere without creating conflicts.
Okay, let's break this down. Replication. That means making copies of the data
Yes.
and spreading them across different machines.
Exactly. And there are different approaches to replication, each with pros and cons.
Yeah.
One common approach is single-leader replication. Imagine one machine acting as the captain. All the new data goes to this leader first. The captain then makes sure this data is copied to all the other machines, the
So
followers.
it's like a hierarchical system,
Yes.
with one machine calling the shots
Yeah.
and keeping everyone in sync.
Yeah. In a way, yes. This approach is relatively straightforward, but it has a vulnerability.
Okay.
If that leader machine goes down,
Uh-oh.
the whole system can be disrupted.
Makes sense. And I'm guessing there are other approaches to address that single point of failure.
Right.
Like, what if you don't want to rely on one single leader?
You're thinking ahead. There's multi-leader replication, where you have multiple captains,
Okay.
each capable of accepting new data.
Okay.
It's great for situations where you have multiple data centers, but it brings its own set of hurdles.
Like what? I imagine keeping everything consistent between multiple leaders could get tricky.
You hit the nail on the head. One of the trickiest parts of distributed systems is maintaining consistency, making sure all those data copies are in sync. Ever updated your profile on a website only to see the old version pop up again later?
Ugh, yes, the worst. It's like the website is gaslighting you.
It could very well be a replication lag issue. The changes you made on one machine haven't reached all the others yet, leading to that frustrating experience.
Right.
And this is just one tiny example of the things you have to think about with distributed data.
So it's not just about spreading the data around.
Right.
It's about carefully managing how those copies are updated and kept in sync.
Yes,
It's like a complex dance to make sure everyone has the right moves at the right time.
exactly. And speaking of complex dances, let's move to a topic that's changing how we handle data: the rise of stream processing.
Ooh. Okay. Stream processing. That's all about dealing with data in real time.
Well,
It seems like everything is moving towards instant updates, live feeds these days.
absolutely. And the book uses a really helpful analogy to explain the difference between batch processing, which we've been discussing, and this exciting world of stream processing.
Okay, I'm all ears. I love a good analogy.
Think of batch processing like baking a cake. You have all your ingredients measured out, you mix them all together, and then you bake it. A complete process from start to finish. Stream processing is more like being a chef in a busy restaurant.
Okay, I can already see where this is going.
Orders are constantly flowing in,
Right,
and you
yeah.
have to prepare each dish on the fly, making sure everything comes out perfectly and at the right time.
So batch processing is dealing with a set amount of data, while stream processing is like managing a never-ending river of information.
Precisely. And this shift towards real-time data has led to some incredibly powerful tools and technologies.
Like what? What are these like real-time data wranglers that we need to know about?
One of the most fascinating is the message broker, sometimes called a message queue.
Okay.
Think of it as a central hub, like a post office for data. It gathers all those real-time data streams, stores them safely, and then distributes them to wherever they need to go.
So it's like the central nervous system of like real-time data flow, making sure everything gets where it needs to be.
That's a great way to put it. The book explains how message brokers use a log-based approach, similar to what we talked about earlier, to make sure no data is lost and that everything arrives in the correct order.
Logs again. They really are everywhere in the world of data systems, aren't they?
For good reason. They're a reliable way to keep track of everything, which is essential for both batch processing and stream processing.
Okay.
But we still need something to actually make sense of these data streams, right?
Right. The message brokers collecting and distributing, but what about actually processing the data?
That's where stream processing frameworks come into play. These frameworks are like setting up a system of pipes and filters for your data streams. You define the operations you want to perform, filtering, transforming, even combining data from multiple streams, and the framework handles the rest.
So it's like programming, but instead of working with static data, you're working with this constant flow of information, making decisions and calculations on the fly.
Exactly. And this introduces some fascinating challenges. For example, you can't just load an entire never-ending stream into memory like you might with a batch job.
Right, because it never ends. So how do you even begin to tackle that?
Stream processing frameworks use a technique called windowing, which is a way to create manageable chunks of data from that continuous flow.
Windowing. Okay, that sounds intriguing. It's like taking snapshots of the stream at specific intervals, right?
Exactly. Imagine you want to analyze website traffic in real time. Instead of trying to analyze every single click at once, you might use a 1-minute window to look at all the clicks that happened in that time frame. Then you process the next minute, and so on.
It's like breaking down a massive wave into smaller, more manageable ripples.
Precisely. And this allows you to perform calculations and aggregations on those smaller chunks of data, making it possible to extract meaningful insights from that never-ending stream.
This is all, like, mind-blowing stuff.
Yeah.
But I have to ask, what's the connection between stream processing and databases? They seem like separate worlds.
They might seem separate, but in reality, they're becoming more and more intertwined. Remember how we talked about message brokers using logs?
Yes.
Well, databases are starting to use similar techniques to capture changes as they happen, almost like a real-time feed of updates.
So you're saying you can almost treat changes to a database like its own data stream.
Exactly. It's a powerful concept called change data capture. For example, imagine you have a database that stores all your customer orders.
Okay.
Instead of constantly querying the database for the latest sales figures. Right.
You could capture those order updates as a stream.
And then use a stream processor to feed that data into like a live dashboard,
Yes.
showing the latest sales figures in real time. That's incredibly cool.
It is.
Yeah.
This approach opens up a ton of possibilities for things like updating search indexes, triggering notifications, and even keeping different systems in sync.
Databases and stream processing working hand in hand. It sounds like the future of data is all about building systems that can adapt and react to changes instantly.
Absolutely. And this idea of interconnectedness, it extends beyond just databases and stream processing. The book talks about the concept of unbundled databases, which is another fascinating trend.
Unbundled databases. Okay, now you're just messing with me, right? What does that even mean? It's about moving away from the idea of a database as this one-size-fits-all solution, and instead breaking it down into smaller, more specialized components.
So instead of one giant system trying to do everything,
Right.
you pick and choose the best tool for each specific job.
Yes.
Like building a custom data solution with the perfect set of tools.
You got it. You might use one system for handling those rapid transactions, another for analyzing massive amounts of data, and something else entirely for searching through text.
That sounds incredibly powerful and flexible, but I imagine it also comes with a whole new set of challenges.
Of course.
Yeah.
One of the biggest is figuring out how to integrate all these different systems seamlessly. How do you make sure they can talk to each other and that data flows smoothly between them without causing inconsistencies or errors?
Yeah, it seems like things could get messy quickly if you're not careful.
It definitely requires careful planning and the right tools for the job, but it's an exciting area of development.
Yeah.
Imagine a world where you can build custom data solutions perfectly tailored to your specific needs.
Right.
That's the promise of unbundled databases.
That's a future I'm excited to see unfold. This deep dive into designing data-intensive applications has been eye-opening. We've gone from the fundamental building blocks of reliability and scalability to the mind-bending world of distributed systems and the real-time magic of stream processing.
And we've only scratched the surface. This book is packed with so many more fascinating concepts and insights.
It's a must-read for anyone who wants to understand the technology that powers our lives and get a glimpse of what the future holds.
It's a reminder that we live in a world increasingly driven by data. Understanding how it's stored, processed, and utilized is more important than ever.
Well said. For all our listeners, be sure to check out Designing Data-Intensive Applications if you want to dive even deeper into this fascinating field. And until next time, keep exploring and stay curious.